So today we learn about superposition theorem, which is in our syllabus. So why we use superposition theorem to solve a network? So basically, first thing, to determine a current in a particular branch when two and more sources are present in a network. Okay. Second thing, it is very easier to solve this network without using any differential analysis. Okay. So first thing, we will solve a circuit to explain the superposition theorem. Okay. So first, in superposition theorem, the first step is to calculate the redraw a circuit by replacing another circuit by short circuit or open circuit. If we replace a voltage source, then the branch will be short circuited, and if there is current source, the branch is open circuited. Okay. So first, this is our network. First we have to consider this voltage source, which having value 5 volt. And here is a voltage source which is 12 volt. So first we have to consider this voltage source in step number 1. In step 1, considering high volt voltage source. So first thing, what is our N? We have to calculate current of this 40 ohm resistance. So in step 1, we have to short circuit the 12 volt voltage source here. The 12 volt source will be get short circuited. Yes or no?
Yes, sir.
So I am redrawing the circuit. 5 volt source. The 12 volt is short circuited. This is 40 ohm resistance. This is 20 ohm and 30 ohm. Okay. This is our target resistance or target branch. I am taking current IS. So according to superposition theorem, we have to calculate individual current of 5 volt source and 12 volt source, then we have to add it. Okay. So first I am taking 5 volt source and calculating IS. So there is several methods to calculate IS. First one, we can use our KCL, that is node analysis. Second method, that we can use mesh analysis. Third method, we can use Ohm's law and current division rule. Okay, these are 3 methods that we can easily calculate the current IS. So I am taking this first analysis, that is node analysis. Okay, so in this circuit there is 2 number of nodes. So first thing, what is node? Node is basically where 2 or 3 branches are meet at a point. So I am taking these 2 nodes to analysis the current in 14 ohm branch. So first in node analysis, one node is taken as reference node or zero potential node, and another node which we have to taken a value. I am taking here V1. So the current flowing this in 20 ohm resistance will be V1 minus 5 divided by 20 by Ohm's law. So V1 minus 5 divided by 20 plus current through this resistance will be V1 by 40 and current through this resistance will be V1 by 30. So according to Kirchhoff's current law, the sum of current is equal to 0. By solving this equation, we can calculate V1. So I am taking first LCM of this 3 denominator. So my LCM will be 20, 40, 30. So LCM will be 120. 120 divided by 20 equal to 6. So here we can multiply it 6 V1 into 6 V1 minus 30 plus 120 divided by 40 equal to 3 V1 plus 120 divided by 30 equal to 4 V1, which makes equal to 0. So 6 V1 plus 3 V1 plus 4 V1 equal to 13 V1 minus 30. So 120 will be gets here, which is equal to 0. So 13 V1 will be equal to 30 and V1 equal to 30 by volt. The potential at this point V1 is equal to 30 by 13 volt. So according to the our target resistance is 14 ohm. So ideas will be here V1 by 40. Okay. So the ideas current will be V1 by 40. Okay. So ideas will be V1 by 40. That is V1 is 30 by 13 divided by 40, which is equal to 0.057 ampere. So in step 2, we have to consider 12 volt voltage source and to remove 5 volt source as a short circuit. So here we can also apply nodal analysis by taking the potential here and a reference here. Okay, so this is my 20 ohm resistance. And this is my 30 ohm resistance. The current flowing through this resistance will be V1 by 20 ohm. Current flowing this resistance is V1 by 40 ohm, and current flowing this resistance is V1 minus 12 by 30 ohm. So according to KCL, the sum of current meeting in this point will be 0. So V1 by 20 plus V1 by 40 plus V1 minus 12 by 30 equals to 0. By taking LCM 120 by 20 equal to 6 V1 plus 120 by 40 equal to 3 V1 and 120 by 30 equal to 4, that is 4 V1 minus 48, which is equal to 0. Again 6V1 plus 3V1 plus 4V1 equal to 13V1 minus 48 equals to 0. This 120 is multiplied here, which is equal to 0. So 13V1 equal to 48 and V1 equals to 48 by 13. Okay. Next, the I double dash will be V1 by 40 here. I double dash will be V1 by 40. So V1 my is here 48 by 13 divided by 40, which is equal to 0.09. 0.09 ampere. Okay. After calculating the current of 40 ohm branch, then we have to make a table. In this table, first column, just write 12 volt source and 5 volt source. Current value I double dash and I dash, and here you can say direction. In both the circuit, the direction is downward. In both the circuit, the direction is here. I dash is downward direction. I dash is in downward direction, and in this I double dash also in downward direction. So my I dash value is 0.057. Just write it here. And I double dash is 0.09. Okay. If the direction is same, then just add it on. According to superposition theorem, we have to add both these currents to calculate the net current when both the voltage sources are present. That means total current will be 0.147. So again I am repeating the steps for this circuit. So first I consider 5 volt voltage source and calculate I dash, which is equal to 0.057 ampere. Then I consider 12 volt voltage source. Then I calculate I double dash, which is 0.09 ampere. Okay, then according to superposition theorem, I sum it, or I added it, I dash and I double dash. The net current will be I dash plus I double dash, which is equal to 0.147 ampere. Okay. Three things you have to remember. First thing, when voltage source is present, so when it is replaced, it is short circuited. So I am making a table for better understanding. Voltage source when replaced got short circuited, and current source got